data flow model. Okay. In data flow model, we will write a code for these 4:1 marks. Now, before going to the coding part, now we will see operation of 4:1 marks. Okay. Here, if you see here, there will be a 2 power n inputs and selection lines and one output. This is the basic operation of the 4:1 marks type. Here, if you see, there is a 4 inputs. It is nothing but 2 power n equals to 4. If we put the n plus 2 means, now consider here 2. It is nothing but 2 power 2 is nothing but 4, right? 4 equals to 4, right? So here we have taken two selection lines. Here selection lines were indicated by n, right? So we are taking two selection lines. Okay. Now we will see the basic operation of merge. Okay. Sorry. Now we will see the basic operation of merge. For example, if you observe here the truth table, based upon the selection lines only, the merge will be operates, right? If selection lines both are 0, whatever the value inside the x0, that will came as the output. For example, consider x0 equals to 1 and remaining all of 0. Okay. At that time, the selection line transfer as a 0, 0. These two are selection lines. Okay. I am drawing bottom here. Don't consider this. Okay. If these two are 0 means output will x0, right? According to our truth table. It means m equals to x0. What was the value inside the x0? We are passing 1, right? So m equals to 1. Same for all these inputs also. Okay. Now we will consider one more input. Now another input is consider 1, 1, 1, 0. Okay. Now consider selection lines as instead of 0, 0, consider 1, 1. If it is a 1, 1, what is the output? X3, right? Our output should be X3. M equals to X3, right? What was the value inside the X3? If you see here, 0, right? Now M equals to 0. Now we will see how to write a data flow model verilog code for this. Okay. First we need to give a module keyword. After that we need to give a name. I am giving here data flow. And now I am giving the inputs. How many inputs are there? 4, right? So I am considering here 3 down to 0. 3 down to 0 is nothing but 4. I am giving as a x. Okay. Now two more inputs are there. One is considered as S0 and another one is S1. Here they taken as a C0 and C1 in this diagram, but we are in our code we are considering instead of C we are considering as S. Okay. Now comes to output things. Consider output thing as a Y. Okay. Now we will write a code. We have to use a SN keyword. We are assigning to the output variable, right? So our output variable is 5. Y equals to, now if we give a question mark, it works as a if. If we declare S0, by defaultly it's considered as a 1. Okay. Now this S0 is 1 and S1 is 1. At this time, what will be the output? X of 3, right? Here we are indicating the index. Okay. Why? Because we are declared in an array, right? It means x of 0. It shows the first place, x of 1 shows the second place, x of 2 shows the third place, x of 3 shows the fourth place. Okay. Now we are making the else. This else is applied to this S1. First we are considered 1, right? Now we have to be considered 0. this S0 is not changed right yet. Now this S0 is 1 and S1 is 0. At this time, what was the output? X of 2, right? Now we are closing this bracket and now we are giving else. Why? Because for one variable there will be two combinations, right? One is 1 and another one is 0. We already applied the two combinations. Now what we have to do? We have to be do this variable has to be changed, right? So for that reason, we are keeping a else here. Now this S0 is 0, right? Now we are making S1 is 1. Okay. Now S1 is 1 and S0 is 0. It's nothing but 0, 1. At this time, what was the output? X of 1 will be coming as the output. Now we are making S1 is also 0. If both are 0, X of 0 will come as the output, right? So after that, we need to close the bracket and we need to give a semicolon. Okay. And later we need to give and module. Okay. Just save the code. And now we have to compile our code. So for that reason, we need to give a command verilog and file name. I already created a file. My file name is dataflow underscore marks 4.t. So I'm giving that name. If you see here, zero errors, right? Now we need to write a Testbench for it. Okay. For that, we need to create one more file and one more file. Now I'm giving module max 4 TB. Okay. Then now we have to save this file. Now I'm giving the name as max 4 TB dot t and I save it on time. Okay. It's already exists, so I need to give one more name max w. Okay. Now my file is here. When it comes to TB, what are the inputs that we have to be take it as a data type as each. So I'm giving each. What is the size of our variable in this first case? 3 down to 0, right? So here also in Testbench we need to give a same size 3 down to 0. And what is our variable name x? Now there is two more inputs are also there. One is S0 and S1. That is also inputs, right? So again I'm considering the data type as a rich. Again I'm taking S1, S0 and S1. Now output is by right in our design. When it comes to Testbench, we need to take it as a byte as a data type. Now I am declaring byte. Okay. Now we need to instantiate. Okay. For instantiation, we need to take design module name and place it over Testbench and give as a name. Here I am giving as a name and one whatever you want you can give it. Now we need to be instantiate, right? Dot x dot here sorry x here inside the bracket variable is indicates the TP variable and here dot x is indicates the design variable. Okay. Why we are initiating? Because we are writing design in another file and TP is another file, right? If we are passing values in TP, it won't reflect to the design, right? So for that reason, we need to put some connection to both these. Then only this both two files will communicate. So for that reason, the instantiation we are doing here. After that, we need to give remaining inputs also. We need to instantiate all the variables from design and TP. If you see here, our whatever the values variables inside the design, that all variables I was declared here. and that are connected to the here local variables, right? Now it's completed. Now here we need to take one more keyword. Initial. Initial is nothing but if we give a initial keyword, it starts from the 0 nanoseconds. Okay, begin, and now we need to pass a value type. So what is our input? X. X equals to, here the size of the x is 4, right? 0 to 3 is nothing but 4. We are passing input in the form of binary. So I am giving it here 4 to 3. For example, now we are passes 0, 0, 1. It is nothing but in x of 0, we are passing 1 and remaining all places we are passing 0, right? Now we need to give selection lines also. Now here we are giving x0 is 0 and x1 is 0. So 0. It means what are the value inside the x0 that will print. Here what we are expected output is 1, right? After that we are giving some delay and now we are considering one more input. Okay. 43 0 0. Okay. 1 1 0 1. Okay. Now if you see here, when will be the x1 will print, this is 0, s1 is 0 and s0 is 0 and s1 is 1. So s0 equals to 1 to b0 and s1 equals to 1 to b1, right? Now what is our expected output here? Here it will print x of 1 value, right? X of 1, right? Yeah, x of 1. So here x of 1 contains 0 value, right? That will be our output. Now we will check. Now we will give some more delay and we will pass one more input. Now we will pass 4 tick B. This time we will pass like this. Okay. Now S0 equals to 1 tick B1 and S1 equals to 1 tick B0. It means the x of 2 value will print. It is nothing but 1. Okay. Our expected output is 1. After that, we need to check one more combination, right? First we check 0 0 0 1 1 0. Now we have to be check 1 1, right? So I am giving one more input 4 tick B. Now we are giving all as ones. Okay. Now we are passing 1 tick B1 as 1 equals to 1 tick B1, right? First we started big and right, so we have to be and that thing first and more. Now our coding part is completed. Just process here. Okay. Now we have to be compiled, right? So similar process, verilog our file name. If you see here, it is visible. You can see here our file name, mux underscore 4 mux underscore 4 underscore tdb, right? It is in the format of .p, so we are giving .p. Here you can see our code is successfully compiled. Now we need to simulate, right? So for that reason, we need to give Vlsi and we no need to simulate our design code. Why? Because we are already instantiated, right? Here we are passing inputs, right? So if we simulated this PB automatically, that whatever the inputs here we are declared, that will close to the design. So for that reason, we no need to simulate specially our design. We need to be simulate our Testbench. It is fine. Okay. To simulate, we used to use using keyword here. If you see here, after that we need to give a Testbench module name. So I'm copying my Testbench module name and I'm pressed over here and pressed enter. Okay. After this, uh, it will, okay, wait a minute. It will goes to this tab. Here, just right click on it, add to mail all the items in this. Now, if you see here, all the inputs and outputs were added here. Okay. Now we are already written a test bench, right? We are already passes a four values of input and we check all the four combinations, right? To to see that we need to press here run command. Okay. Now we need to maximize our waveform. If you observe here, and if you observe here, here we are passing first input is 0, 0, 0, 1. It is nothing but in x of 0 we are passing 1 and remaining all inputs are 0. And we are taking a selection line is 0, 0. According to our, if you see, according to our truth table, if selection lines both are 0, whatever the value inside the x of 0, that will come as the output, right? So here if you observe, our x of 0 contains 0, 1, right? So our output is coming here 1. If you see here in this messages column, it is showing output as a 1. Now comes to second one. Now here we are taking 0, 1. Now go back to the truth table. If he passes 0, 1, x1 will be the output, right? Now come back to the waveform. Okay. Here x1 is 0. If you see the second plus, it indicates x1, right? Now this value will be reflected here in the output. If you see here, the output is 0. Now comes to third one. Here we are passing 1, 0 as a selection line. So it will reflect x2 of whatever the input in the x2 that will reflect to output, right? Here if you see here in our input, 1 will be the x2 value, so that will reflect to the output. See here, the output is 1. Now come back, comes to fourth combination. Here we have taken the selection line, both are 1. It means whatever the value inside the x2, I mean x3, it will come as the output. Here x3 contains 1, so it is getting output getting is 1. So this is how we have to be verify uh, the waveform. Okay.